Welcome back, everyone, to the last section in Chapter 3, the last of the derivative rules. We're going to talk about logarithmic functions, 3.3. First, a little review. What's the derivative of an exponential with base e? Well, this was one of the first rules we had. The derivative of e to the x is e to the x. It's its own derivative. Let's do a quick example, something we haven't done before. What's the derivative of e to the sine of x squared? Well, this is a chain rule. Working outside in, what's the first function? It's e. What's the second function? It's sine. And what's the third function? It's x squared. So what is this derivative? It's e to the same thing times the derivative of sine is cosine of the same thing times, what's the derivative of x squared? 2x. Now how you want to write this is your own business, as long as it's, I'm going to do 2x e to the sine x squared cosine x squared. However you want to write it's up to you, but it's just an e problem. The derivative of e to something is e to something times the derivative of a something. So that's something we learned in the very first set of notes on derivatives. But what if it's not e? If it's anything else, then it's the same thing again. The derivative of that, I just have to include a natural log of whatever this is. Now why is it not here? Why is this not here when it's e? Because what is the natural log of e? It's 1, so it cancels itself out. Okay? Let's try a practice problem. This is an exponential that doesn't have e as a base. Instead of e to the tangent of x, it's 13 to the tangent of x. So, it's the same thing again, times the natural log of whatever the base is, times the derivative of the top. What's the derivative of tangent x? Secant squared of x. And that's fine for an answer. I'm going to clean it up. Actually, I don't know how I'll clean it up. I'm just going to put parentheses around it. The order doesn't matter. There's no good way to clean up these problems. These rarely come up on the AP test, but you do need to know the formula. It's the same thing as the e to the x formula, just add a natural log. It's natural log of 13. I don't know why I put natural log of 3. Sorry. Okay? That's exponentials that aren't e. Now let's talk about logs. The last derivative rule you have to learn is natural log. Thankfully, it's really easy. It's 1 over the inside times the derivative of the inside. And this is just here because of chain rule. The derivative of natural log is 1 over whatever. The last one you have to memorize, but you do need to know it. Let's try some problems. What's the derivative of natural log of 2x? Well, I see natural log, so it's 1 over 2x times, what's the derivative of the 2x, the inside? It's 2. If you clean that problem up, it'll just be 1 over x. How about this one? What's the derivative of natural log of x squared plus 1? Well, it's 1 over x squared plus 1 times 2x, the derivative of the inside, which makes it 2x over x squared plus 1. How about that one? X natural log of x. A little bit more difficult. What operation is going on there? You're multiplying. That's a product rule problem. First, derivative second. What's the derivative of natural log of x? It's 1 over x. Times nothing because there's no derivative inside. Plus the second times the derivative of the first, which is just 1. Cleaning this up, what's x times 1 over x? That's x over x, which is 1 plus natural log x. There you go. So natural log is just 1 over whatever's inside the natural log. Okay? Natural log differentiation is pretty easy. However, there is a difficult thing in this section. It's called logarithmic differentiation. In fact, this is so difficult that I think I did a mini lesson on it, so check YouTube for it. I've only seen maybe 1 or 2 of these problems on the AP test, but you do need to know it for the quiz and test on Chapter 3, so be able to do this. Take a look at this problem. This is not exponential because it's not e to the x or 5 to the x or 13 to the x. It's x to the x. I can't do this problem. But can I rewrite this problem to get rid of an exponent? What is the inverse of exponent? What cancels out, what function cancels out exponent? Natural log. I'm going to take a natural log of both sides. Okay? That's legal because I did the same thing to both sides. What do I do with an exponent when I take a natural log? I can put it in front. That didn't help me, except it got rid of the exponent. Now, I need to take a derivative. Well, how do I take a derivative? What's the derivative of natural log of y? We just said the derivative of something is 1 over that same thing. But I took the derivative of something with y in it. 3.2a, implicit differentiation, says that needs a y prime. Right side, we just did this problem. First, derivative second, plus second, derivative first. Cleaning this up, this is saying that y prime equals 1 plus the natural log of x all times y. I can't leave this problem like this. I know that y prime is equal to 1 plus the natural log of x. But what is y? It's x to the x. There you go. Logarithmic differentiation. Again, we do this because I can't take the derivative of this thing. But if I use some logs, I can get rid of some stuff. Okay? If you have any questions, guys, check out the mini lesson on YouTube. In addition, that is it for Chapter 3. So any questions, anything you have trouble with, come talk to me. Okay? Thanks, guys.